All right, so we are classifying quadrilaterals today. We filled in some of these blanks here. This is your cheat sheet. So if you look down here, here's your 6 shapes. Also, just FYI, which you guys have had some experience with this on Delta Math, so if you've seen it, if you know, when it talks about a generic quadrilateral, it just means it doesn't follow any of these properties. So like none of the sides are the same, and none of the slopes are parallel or perpendicular. Like it is just a 4-sided shape, but yet it doesn't have any of these properties. So I guess technically there are 7 possibilities for what it could be. But there's only 6 of them that have like reasons for what it is. So if it doesn't follow any of these, it's going to be a generic quadrilateral, and the reason for it being a generic quadrilateral is just like no sides are congruent and no sides parallel or perpendicular. But yeah, this is your little cheat sheet. So if you think a shape is one of these quadrilaterals is one of these 6 shapes, you have to prove whatever is listed here. If you think it's a square, you got to prove that there's 4 right angles, 4 congruent sides. A rhombus just has 4 congruent sides. So that's what we're going to do. Let's go down here and let's plot this first one. All right. So here's the shape. I drew it. I labeled it. Very important to label it because when you're just looking at these, you don't know which point is which, and it makes it really hard to figure this out if you're just looking at these points. Also, I personally do not like distance formula, so I'm going to show you distance formula one time, and then the rest of the times we are going to use Pythagorean theorem, because that is another option. It's the same thing as distance formula, but since we have a graph, we can use it. It's easy. Or easier, I think. But for this first one, I will do distance formula just to show it to you at least once. So for this, I'm going to find the distance of a B, x1, y1, x2, y2, and I'm going to plug these numbers in. So I want to take 0 minus 3 squared. I'm just plugging x1 minus x2, y1 minus y2, 0 minus 2 squared. Plugging it into distance formula. I might zoom this in a little bit so it's not so tiny. And then what do we have next? All right. Negative 3 squared plus negative 2 squared. And remember, when you, this gets weird when you type it into the calculator, because if you don't use parentheses, it's just going to do negative, and then it'll do 3 squared separately, and it'll make it a negative 9. But negative 3 times negative 3 is not a negative number. You are not going to have negative numbers past this step, this squaring step in distance formula. So it's a positive 9 and a positive 4. That's important. And then you end up with square root of 13. All right, so that is one of them. I think it's easier to do Pythagorean theorem, so we're going to switch gears, and now we have found that the distance of this one is square root of 13. Let's look for the distance of BC, and in order to do that, we're going to create, with dotted lines, a little right triangle, and figure out those side lengths. So we're just going to count, it goes over 2, and it goes down 3. So it's a triangle that looks like this, 2, 3, and then we are looking for that hypotenuse. So we can plug that into Pythagorean theorem. A squared plus b squared equals c squared. 2 squared plus 3 squared equals what we're looking for, that hypotenuse, which is BC. And then if you'll notice, so you see, we're always going to, which is nice about this, we're never having to subtract, we're always just adding these 2 legs that we found on the graph. All right, add these together. 2 squared is 4, 3 squared is 9, 4 plus 9 is 13. So 13 equals c squared. You take the square root of both sides to find the hypotenuse. So you end up with square root of 13. Maybe you can see some similarities between distance formula and Pythagorean theorem. Yeah, because they're the same thing. Distance formula was derived from Pythagorean theorem. So square root of 13 is the length of BC. One thing that's nice about Pythagorean theorem is you can kind of start to see a pattern here of, oh, here's my triangle. Is it the same triangle? Yes, this one is 3 and 2. It's like a different orientation. It's on its side compared to this one. But up to over 3. So CD, 2 squared plus 3 squared, that's going to equal 13 again. So you're going to get the square root of 13. You're going to get the same thing. How do we know that? Because the side lengths of this triangle are the same. And then we have one left. So it's just important to count each one. Don't just assume. At least look at it, count it. Use the graph that you're given. So we've got 2, we've got 3. And it's going to be the same. It will be the square root of 13 because if we plug in the same numbers, you're going to get the same answer. So square root of 13 would be our side length. Ah, all 4 sides are the same. So we are going to look at that up here, and we're going to see only 2 of these shapes have 4 congruent sides. So that narrows it down quite nicely. It's not going to be any of these. It's not going to be parallelogram, rectangle, trapezoid, or kite. It can only be a rhombus or a square. So let's continue on. Find the slopes and determine, is it a square? Are there 4 right angles? Or is it a rhombus where there's not 4 right angles? All right, so check for right angles and parallel sides by finding these slopes. Let's do that. So I'm going to start at AB, and I'm going to just count the slope. It goes up 2 and over 3. You can use slope formula if you'd like, if you just want to use these points. I think it's a lot easier to just count it on the picture, so that's what I'm going to do, but it's up to you. There's multiple ways to solve it. So AB goes up 2 over 3. Make sure you're counting the right things. You're counting the rise over the run. So the change in the Y value, the up and down, is going to go over the side-to-side change. Because if you start mixing that up, you're going to get it wrong, and it's going to be confusing. All right, so 2 over 3. All right, and then the slope of BC, it goes down 3 over 2, so negative 3 over 2. I saw a lot on that project of people putting positive slopes when it should have been negative. Just because they're going too fast, not paying attention, and, well, that was really bad for the project because it messed up all your math and your pictures, and everything was ruined. So don't do that. On this one, the slope of CD, it goes up 2 over 3, and we're just counting the rise over the run. Kind of nice because we've already labeled it for distance formula. Some of them you will have to simplify. This one you don't. So that's nice. And then slope of AD, so find D, go to A, goes down 3 over 2, so negative 3 over 2. All right, things that we should be noticing. We've got these opposite sides that are parallel. So like AB is parallel to CD. And BC is parallel to AD. So these are some things that we should be noticing. Did I write anything crazy on here? These slopes are correct, right? Not seeing anything? Let me know if I put something down that's wrong. Yeah, so these things are parallel, which is, we need that for both a square and a rhombus because they follow all those properties of parallelograms as well. But we're also really looking for right angles to determine, does it have right angles or not? And then here you can tell, okay, is 2/3 the reciprocal of negative 3/2? Do they get flipped, and does the sign change? Yes, both of those things happen. Make sure you pay attention because sometimes it just gets flipped and the signs don't change. Or just the signs, you know, like just pay attention to this because you do actually have 4 right angles. So we're going to go back to this and we're going to mark these right angles because if you compare each one of these, comparing these two, that forms a right angle. These two form a right angle. These two form a right angle, and where these two intersect, AB and AD, they form a right angle as well. So 4 right angles are formed. There's different ways to write this, but just the fact that they are opposite reciprocals, we've drawn it on our quadrilateral. That's good enough. So this is going to be a square. How do we know that? Well, we look up here. Have we proven these things, that there are 4 right angles and 4 congruent sides? Yes, we have in our steps 2 and 3. So we can just write that, 4 right angles. This is what our shape on the next page looks like. Instead of using distance formula, I'm going to use Pythagorean theorem, but 2 of these you just count, which is really nice. A to B, it's 5 units long. How do I know that? I'm just counting the spaces in between. 1, 2, 3, 4, 5. And then CD is also 5. Super nice. You don't have to use any formulas. This one goes up 4 over 3. So that is my triangle. Up 4 over 3. So same thing with this one. They are the same shape, right? So this is the same triangle. So therefore, AD and BC are going to be the same. We just need to figure out what they are. 3 squared plus 4 squared. equals c squared. Where'd those numbers come from? I drew my triangle and I counted. All right, 3 squared is 9, 4 squared is 16. Add those together, you get 25. All right, here's the deal. When you take the square root, make sure it's simplified. Like this comes out to a whole number. Square root of 25 is 5. Don't leave it as square root of 25 because it makes it hard to compare with the other ones. So this one's going to be 5, and then AD is going to be the same thing because it's also 3 squared plus 4 squared. So they are all the same. Great, we got 4 congruent sides again, so that kind of narrows it down. It's either going to be a square or it's going to be a rhombus. Does that look like there's right angles there? No, but we need to prove that it's not. You can't just look at it. You have to have some sort of way to prove that, and the way you do that is by the slopes. So let's go down here and figure out the slopes. So AB and DC, it is a 0 slope. It is horizontal. Make sure you keep that in mind as far as like horizontal is 0 and vertical is undefined. Like don't get those mixed up. And then let's find the slope of BC and AD. So they go up 4 and over 3. Each one of them goes up 4 and over 3. So when we're comparing these, we're determining, okay, well, we do have some parallel slopes. The opposite sides are parallel to each other. So the sides that don't have any matching letters are opposite. AB is opposite of CD, BC is opposite of AD. So that's good because you need that for a rhombus. But there's no perpendicular slopes. So there are no right angles. So what we know is that this is going to be a rhombus. How do we know that? Because we have 4 congruent sides, and that's all you have to write. So less to prove here. If you think it's a rhombus, you prove that there's 4 congruent sides, and then we use the slopes to determine, okay, there's actually no perpendicular slopes, therefore there's no right angle, so it cannot be a square, which is the only other thing it could be with the 4 congruent sides, just based on our little cheat sheet up here. But yeah, that's pretty much it. Let's real quick look at this page. All right, so number 4 can be a little bit tricky. So I went ahead and I plotted UV and I connected it with a line because this is segment UV, so they're connected the dots here. W needs to be connected with X. The problem is you don't know where X goes, so you need to figure out where is X. It has to be, the X value has to be 4, so it has to be somewhere on this X value, but what is the Y value for this point, X, in order to make UV parallel to WX. So once you see it drawn out, it's a lot easier to see. But basically, what is that Y? There's only one correct answer for this. What is the Y value for X when the X value is 4? Where should this point go in order to make it parallel to this? And then this one down here, number 5, plot the points. There's these 3 points. And then you are going to determine on the coordinate axis below, state the coordinates that would form a parallelogram. Okay, so you're going to plot these 3 points, and you're going to determine where that 4th one can go in order to create a parallelogram. The thing is, with this one, I think there's 3 correct answers. There's multiple correct answers for this particular problem. So you may get a different answer than the person next to you, and you might both be right. But you just need to pick a point for D in order to create a parallelogram where it follows all of those things. The opposite sides need to be parallel and congruent. All right, and then that's all you're doing.